Okay, so I'm going to describe example 2.6. So this is a two-stage problem and using a node variable formulation. So an electricity consumer face uncertainty in the demand and the price for the next week. So we assume that both price and demand are uncertain but constant. Okay. So the consumer has a possibility of buying up to 90 megawatts at $45 per megawatt hour. Okay. So clearly this is a two-stage problem, right? So at the first stage, the consumer has to decide how much to buy from the contract, and the second stage, it has to decide how much it buys from the pool. So in this table, we can see the three different scenarios, right? With each of one with its probability, demand, and price. So in this tree, we see that a two-stage problem, right? So in the first stage, we have to decide how much we are going to buy from the contract. And in the second stage, how much we're going to buy it from the pool. And we have three different scenarios, right? So in total, we have, as you can see, three different scenarios, right? Okay, so this is a formulation. We want to minimize the cost, right? We have four variables. First is the power for the power that we are going to buy from the contract, and the power corresponding to each of the scenarios. Okay. So given that we are analyzing this for a week, right? This is the number of hours we have in a week, right? Prices are in dollars per megawatt hour. They are not in dollars per megawatt. So then that's why we have to multiply the number of hours in the week, right? So this is dollars per megawatt hours, and this is power in megawatts. Okay? So you can see all the units are consistent. Okay, so the first term corresponds to the cost for the contract. Second term, the cost for the first scenario, second scenario, and third scenario. Okay, the constraints are as follows. The first constraint says that the power we buy from the contract plus the power we buy from the pool in scenario 1 has to be greater than 110. Okay, because remember that the demand, right, in the scenario 1 is 110 megawatts. Okay, so we have to at least meet the demand. Okay, this could be equal, could be greater or equal, doesn't matter, right? Because we are minimizing a cost function, so it doesn't make sense. It doesn't matter. Similar for the second constraint, right? The power we are going to buy from the contract, the power we are going to buy from the pool in the second scenario, and for the third scenario. Here we have a constraint related to the how much power we can buy from the contract from 0 to 90, and the non-negativity of the powers in each scenario, right? And the solution to this problem is 80 for the contract, 30 for scenario 1 and the pool, 20 for the pool in scenario 2, and 0 for the pool in scenario 3. Okay. Now let me show you the code. Stop share here and okay. So here I have the code for this example, right? I'm going to use Python, Gurobi, and Jupyter Notebook. Okay. So here I define the data. I have three scenarios, 160 hours per week. I use dictionaries to store the probabilities for each of the scenarios, the demand for each of the scenarios, and the price for each of the scenarios. Okay. I'm creating the model over here. Then I have the variables, right? PC for the contract and PI for each of the scenarios. Okay. For PC, I set a lower bound 0 and upper bound 90 because that's the minimum and maximum power I can buy from the contract. This variable is a continuous variable. For PI, I index it by the scenarios, P1, P2, P3. Its lower bound corresponds to 0, the non-negativity constraint, and it's a continuous type variable. We update the model, we define the objective. Here I'm going to, the first term corresponds to the cost for the contract, and the second term corresponds to the cost for each of the scenarios. Okay, I'm using a quick sum, right? Multiplying probability, price, and PI as we saw in the PDF for each of the scenarios. I set the objective. Okay, sorry, this is minimize, not maximize. And we set the constraints as we saw. So it's PC plus the power of each of the scenarios has to be greater than the demand. Okay. So we update the model, we optimize. This is the objective, the cost, total cost. And then I use this code. You can double check it for visualization. As you can see, we have the same, right? 30, 20, 0 for each of these scenarios, and the contract, the power of the contract is 80. Okay, so that's it for this example. Thank you for watching.